Last episode, we spoke a little bit about FAR-ML, a neural net trained on a supercomputer at the cutting edge of molecular science. And it's not just science. AI is making waves in all kinds of industries, but despite the incredible results we're able to achieve, when it comes to the world of work, there are a lot of misconceptions.
AI will take my job. AIs are robots. AI in science fiction. The fact that AI is a black box, I don't understand what happens inside it. And there's lots of confusion about AI and ethics.
This week, we look at AI and the future of work, from job displacement to educating the next generation, to find out where AI can be used to change our jobs for the better, how automation and algorithms are affecting employees right now, and how long I've got before I get replaced by a text-to-speech program. My goodness. All that and much more. I'm Michael Bird, and this is Technology Untangled. A recent survey by the European Commission found that 42% of companies already use at least one form of AI, with another 20% planning to adopt it in the next 2 years. Like many people, your first thought might be, is AI going to take my job? And it's a fair question. After all, technology has been making jobs obsolete for centuries. And it's actually what I asked Matt Armstrong-Barnes, Chief Technologist of Artificial Intelligence at Hewlett-Packard Enterprise.
Job displacement is happening. The jobs landscape is changing as a result of the fourth industrial revolution. Robots are a significant factor in that. Just looking at the AI piece, what we need to think about is what's AI great at? Classification and regression and doing things at scale. A lot of the problems AI is tackling can't be done by human beings anyway.
Good point. The first thing to note is the separation of AI and robotics. These are actually totally different fields. They do overlap in the form of artificially intelligent robots, but that's a cutting-edge technology that's very much in its infancy, not something we'll encounter today in the workplace. So, where is AI right now? Well, to understand that, we need to make a distinction between strong AI and narrow AI.
Strong AI is AI that is operating at the same level as a human being. We're not there yet. That is the stuff of science fiction. The debate in the academic community is it will happen anywhere between the next 10 and 90 years.
All AIs we're dealing with right now are narrow or weak AI. They can operate on just one task. There are many forms that these narrow AIs can take, but the important ones to know are machine learning and deep learning.
Machine learning is a machine that is capable of learning without being explicitly programmed. Traditional programming requires you to have statements that are, if this happens, then do that. So I have to tell the computer what to do. A machine learning algorithm looks at a set of data and learns from that data. Regression and classification. So if you were to hit a retailer's website, what they really want to do is, based on your buying preference, they want to classify you, they want to group you with other people with similar buying patterns, and they want to make predictions of what you're going to buy next. So this is recommendation engines. You can achieve that with machine learning. If we start to look at more complicated things like recognizing objects inside images or understanding speech, you need to move to the next stage really of artificial intelligence, which is deep learning. So this is using this concept of an artificial neural network. You feed in lots and lots of pictures of what you want it to recognize, and the machine learning algorithm, the deep learning, will start to recognize those images. And as a result, when you show it an image that it hasn't seen before and been trained on, it will then make a prediction as to what it thinks the object inside that image is.
AI becomes particularly useful when we have to deal with huge amounts of data. In healthcare, for example, it's become easier and cheaper to produce medical imagery. And because we're not producing qualified people at the same rate, AI can help us to fill that gap.
AI doesn't diagnose, but it can prioritize workload. So we're working with a startup in the Netherlands, Nicolab, and they have built an artificial intelligence that looks at brain imagery, and it is specifically looking for bleeds on the brain. So if anyone who's had a stroke themselves or had a family member or friend who's experienced a stroke, they'll know this is time critical stuff. You need to get somebody who has a bleed on the brain to the right specialist as quickly as possible. So what the AI does is it looks at this imagery. Firstly, it works out if there is a bleed on the brain. Secondly, it will route it to the relevant neurologist, who may be in a different hospital, to work out whether or not there is a bleed on the brain. And once the medical professional has done that diagnosis, the individual can then be routed as quickly as possible to the right medical facility that can handle this kind of neurological impact.
At its best, AI can be used to take away those laborious, mundane, or data-heavy tasks in a way that actually enhances our ability as workers.
The most successful implementations of AIs are when they're augmented with humans. Chess. AI has beaten chess grandmasters. However, when you put a grandmaster and an AI together, they're more successful than AI on their own.
A helping hand from AI. Nice stuff. And I mean, from where I'm standing, it doesn't really sound that problematic. And actually, in and of itself, AI isn't really a problem. It's just a mathematical equation. The problems seem to arise all around it. And the primary ethical consideration we hear about all the time is the B word: bias.
Not all AIs have an inherent bias challenge. If you're building an artificial intelligence model that is looking at pressure valves inside a production plant to work out when one is going to fail, that's not bias. Bias comes into play when you start looking at AIs and how they relate to people.
When we talk about bias and AI and machine learning, one of the outputs that we see is just a basic anomaly in decision making.
Toju Duke is a responsible AI program manager at Google in Dublin and a member of the non-profit organisation Women in AI. When it comes to bias within AI, Toju says it's all about the data.
We have something called correct ground truth or incorrect ground truth, and it's basically just labeling the data that is used in the data sets to build these machines. And the most accurate form is when humans label these data sets. There's so many times we've seen the output of, just doing a very quick search for a woman with unruly hair. And the search results that tend to come up are women of color with curly hair. And Caucasian folks come up when you do the search for professional hair. The human raters who labeled these data sets, they were used to thinking that professional hair is nice and straight.
Machine learning AIs are trained on datasets, so if humans have labelled data in a biased way, the output can carry those biases forward. In a similar way, if we have incomplete datasets based on historical data, our out-of-date biases can be exponentially proliferated.
We had a recruitment software made by a big tech company, I'm not going to mention names here, and it was used for about 4 years. And along the line, we realized that it was biased towards women, where if it saw a woman's CV that had the term women's college, it dropped those CVs. So they were not even called for interviews at all. And when you ask why was this the case, it was built, of course, by, I feel, a male-dominated team who did not think about diversity. But beyond that, the data sets were inclusive of all male CVs because it was using the data sets of the people in that company. And as a typical tech company, it was male-dominated. So it was trained on 70% or 80% male CVs as opposed to female. And the system just learns to recognize the keyword man and men's colleges, and anything that didn't fit within those keywords, it just kicks them out.
The AI wasn't necessarily doing anything wrong. It was kind of doing exactly what it was designed for, but it wasn't given the right data.
Exactly. So that's always a problem. It's like the data is never conclusive enough. It's just not fully encompassing.
AI is going to do one of two things when it comes to bias. It's either going to help eradicate it, or it's going to exponentially increase it. Whenever you start on an AI journey and it relates to people, make sure that you use all of the tools and techniques available, of which there are lots, to evaluate the data that you're using to train your algorithms to identify and eradicate any bias. Look for gaps in your data set.
Clearly, organisations that create and use AIs need to rigorously assess their datasets. And once we eradicate bias, we're free to use these time-saving machines to our heart's content. Thank you so much for tuning into Technology Untangled. We'll see you for the next... Oh, I'm only joking. If only it was that simple. You see, when it comes to the world of work, biased hiring algorithms are just the tip of the ethical iceberg. It's less about what the AI does and more about how it's being used. In November 2020, the UK's Trade Union Congress published a report titled Technology Managing People. Here's Employment Rights Policy Officer Mary Towers.
We are very pro-innovation, but very anti-unfairness. So what we want to do is make sure that the worker voice and the worker experience isn't lost in the course of this, essentially a revolution, a technological revolution that's happening in the workplace.
The TUC represents the vast majority of England and Wales's trade unions that amounts to about 5.5 million people. For their report, they wanted to investigate the extent to which AI is being used in the workplace throughout the entire employment relationship and what that means for workers. From hiring to task and team allocation, performance ratings, disciplinary action, and even termination.
What we found was that AI was being used to make decisions in almost all of those areas. About 60% of people that responded to our survey had experience of technology in training, around about 50% in monitoring and surveillance, and then just over 30% in recruitment. So nearly 20% of people had had experience of some form of automated CV scanning process, just over 10% of social media screening, and about the same had experienced AI-powered psychometric testing. There was a relatively low experience of things like facial recognition technology and speech recognition technology being used in recruitment, but it was still around about sort of 3% or so. So sometimes FRT is used in interview processes to analyse facial expressions and to then grade people according to facial expressions. So a technology that at the moment would appear to be being applied at a fairly low level, but a big question on our minds is the technology being used, but actually people just aren't aware of it?
And it's not just in hiring. The report found technology was being used to make line management decisions. That could include decisions around how you carry out your role, decisions on your personality type and coaching needs, timetabling of shifts, the list goes on. Most people assume AI will replace low-skilled jobs, but actually, middle management is predicted to be at the highest risk of automation. The thought being that if you can get the algorithm deciding on shift patterns, why wouldn't you save on the overheads? But allowing AI and technology to shape our workplaces has a range of ramifications on the workers themselves.
The first really, really significant issue that came across from our research was that workers' physical and mental health is really suffering as a result of the application of some of these AI-powered tools. So real-time monitoring seems to be a particular source of stress and unhappiness, as did a sort of general sense of loneliness and isolation that came across when people were experiencing being managed by these types of tools rather than being managed by a person. So one worker told us that going to work is not enjoyable anymore as you're scrutinised and watched over constantly. And another said that knowing that there's monitoring software installed, whether it's active or not, makes work more stressful. I feel like I have to second guess everything I do and can't relax at work.
Another common thread in the TUC's research was the anxiety caused by not understanding how AI was being used to make decisions. As we know, AI algorithms can't really be inherently unfair, but the way we put them to use can.
We had reports of call centre users who knew that certain people were getting allocated certain types of calls. They were the calls that were more likely to have a positive outcome, which was then connected to bonuses. They knew there was some kind of automated system in place that was analysing how people were dealing with calls and then making a decision about who got which calls. But of course, the outcomes were ultimately unfair because it's not like in the middle of that process, anyone was saying to the workers, well, look, this is what you're getting wrong in your calls. This is how you can improve. And then you'll get allocated the calls that are more likely to lead to performance bonuses, for example. So a lot of workers had a sense that something was unfair, but they didn't know exactly how the unfairness had been caused, and therefore they couldn't challenge it. And that in itself caused quite serious deterioration in people's mental health.
So the obvious answer would seem to be transparency. Employees should be able to ask their employers exactly how AI and algorithms are being used. However,
actually, a lot of the employers don't understand themselves how the decisions are being made. So you're then really stuck because where do you go with that? There just isn't anyone to communicate with who understands how the technology is making the decisions. So knowing there's unfairness, not being able to challenge it, having real difficulties challenging the decisions, and finding that, number one, employers don't really understand how the technology works themselves, but number two, an assumption often by employers that technology must be right. And then when workers meet that brick wall, then it causes mental health problems.
This human health and well-being element absolutely cannot be ignored. Back in the 1800s, the advent of factories meant the health of workers actually declined, which ultimately led to public health services being established. Now, we're in the age of data and efficiency, and in a rush to maximise the great commercial potential advantage of technology, the worker experience risks being overlooked.
You've got unreasonable targets that are being set for people because the data might suggest that a task can be completed in X period of time, but that data might not have taken into account various different environmental context issues. One worker said that they felt that they were just being viewed, and I quote, as a series of statistics measured against an arbitrary level of performance. This isn't the fault of the technology, but it relates to the way that technology is being used by employers. And I think there is an increasing awareness now amongst employers, amongst technologists, amongst government, amongst legislators, that actually it is really important to recognise workers in this process.
Now, it's worth noting that in the UK, existing laws like the Equality Act, privacy laws, and data protection legislation do offer some degree of protection. But there are plenty of gaps in the existing laws that need filling. So the TUC is planning to publish a legal report this spring that makes proposals for legislation.
We're making proposals which are geared at securing greater transparency over how these different forms of technology work. It's also an important principle that the information that people have access to is actually understandable to them. We also feel that just as a very basic standard, people's data should not be processed in such a way that the outcome is any form of discriminatory decision that's being made about them. And then we'd also like to see greater control over worker data taken by workers themselves. I'm sure that many of your listeners will know that data is essentially at the heart of artificial intelligence. And there isn't really any particular reason why that information should be used for commercial gain and for efficiencies at work, and yet workers not be able to use it to advance their own interests. So something we're very interested in doing is trying to redress that imbalance of power over data. And we feel quite strongly that trade unions are very uniquely placed to do that, because one of the fundamental values of the trade union movement is the importance of collective action.
The TUC wants to empower workers to achieve transparency around the use of AI at work. And it's resonating with a lot of organisations too.
Having spoken to some HR directors from some quite big companies, it's obvious that they are finding the same difficulties with understanding and communicating over these technologies that we have. So why don't we help each other? So work with us, listen to workers, understand the tech, communicate with technologists so that when the product is produced, that product actually matches the need. Because one of the things that happens is that often these tools are put in place, but actually they don't match how the employment relationship works. They're not matching the requirements, the human resource requirements. So employers need to communicate with technologists about that. These issues matter for everyone because at the heart of the debate are questions around how do we value human beings and about treating human beings with dignity and with respect and not allowing the technology to steamroller those principles.
If you'd like to read more about the TUC's work, proposals and manifesto, then you'll find lots of links in the episode show notes. AI at its heart is just mathematics. But when you apply it to the world of work, we have to add that human coefficient. We'd never allow a doctor AI to diagnose patients without having a professional to check its results. And that level of checks and balances needs to apply anywhere where people are involved. Part of the worry is that AI and automation is exploding in the workplace, and mistakes can be made if we deploy too much too quickly. You might remember in the very first episode of Technology Untangled, Matt Armstrong-Barnes said,
"There's been some recent analysis that says AI will get rid of something like 1.9 million jobs, but it will in fact create 2.3 million jobs."
But what happens when you add an accelerant like COVID-19? Over the past year, organisations have struggled to avoid workplace infections and keep operating costs low. Alana Samuels, senior economics correspondent at Time, wrote that the US lost around 40 million jobs at the peak of the pandemic, and while some have come back, some will never return.
So there are a number of industries that have been changing anyway. COVID-19 has been a massive accelerant to that, which is part of the reason that we're seeing some of the challenges in the job space. And AI does play a role because it's accelerating the transition that people are needing to make into these new jobs. If we were to take COVID-19 out of the equation, a lot of those industries would change over a longer period of time. If I give you an example, you could argue that the traditional fashion high street retailer is in decline, whereas grocery retail is increasing. So the job market is shifting. People are moving from fashion retailers into grocery retailers. And over time, they would have made that natural progression anyway.
It's true that the jobs market goes through phases. In the Industrial Revolution in the 1800s, the cotton mill absolutely obliterated the handloom. And in the 2000s, the likes of Napster and LimeWire brought the CD industry to its knees. But out of the ashes comes something new. Airbnb instead of travel agencies. The return of the boutique vinyl shop.
When it comes to workers in general, it is about understanding where that shift is happening to. So if there is a specific set of roles inside an organization that are being changed by the implementation of AI, then it is about what skills do those people need to transition into those new roles.
COVID is likely to have catalysed a temporary but very real amount of job displacement, and there's no quick fix. Organisations have a responsibility to understand which jobs are likely to be made redundant and try to mitigate that through retraining. But a lot of the onus will fall on individuals. So many of the misconceptions around AI come from the fact that a large majority of people just don't understand it. It's new, it's unexplainable, it's a black box. And actually, this could be the biggest issue of all.
I do think there's a different challenge that needs to be addressed, and that is education. We're seeing a decline in the number of computer scientists. that are coming out. It's seen as a geeky discipline. Fewer and fewer people want to get involved in it. So we need to make sure that we understand how we can get children involved in these kind of activities so that they want to go through the educational process and come out not ICT fluent, which is, can I use PowerPoint? Can I use Excel? But we need them to come out as being computer science literate. Do I understand how computers work? Do I understand computer science concepts like artificial intelligence? Or do I understand that it is a tool and how I can effectively use that tool to help me tackle the problems that I'm going to encounter from a business context perspective?
A popular, though unsupported, estimate predicts that 65% of children entering primary school today will ultimately end up working in completely new jobs that don't exist yet. We're now working alongside the relatively simple AIs that do regression and classification, and we're running into trouble in terms of our understanding and their explainability. So, how on earth are the next generation going to handle it?
Somehow, digital stuff is going to infect everything. And if you know nothing about how it works, you are the servant of the computer and not its master. How often have you heard people say, computer says no, or I can't do that, the computer doesn't let me?
That's Simon-Peyton Jones, a computer science researcher for Microsoft in Cambridge and chair of the Computing at School group and the National Centre for Computing Education. Simon was deeply involved in enacting massive reforms in the UK's computer science curriculum.
I got interested in computing education because I sat round the dining room table with my children, asking them, as you do, what they did at school. When they started talking about their education in computing, they were kind of openly contemptuous. They regarded it as a sort of joke subject. And so I was struck by the contrast between that and, say, natural science, where what happens at school is recognizably the same thing that a real scientist does. What they were doing at school, they were talking about learning about how to use PowerPoint. And I thought that isn't recognizably the same subject that I think is so fascinating that I've devoted my professional life to it entirely. So, does not compute. These two things don't join up. So I started to talk to more people about their experiences, and everybody seemed to agree, well, what we are teaching our children at school about computing is bonkers, but hey, it's the education system, and what can you do? It's got so much inertia, you'll never change it. But I began to think that if everybody thought that, right, and there wasn't a big group of people invested in the status quo that really thought it was the right thing educationally, then maybe if we just all spoke with one voice, perhaps something could change.
Simon and a guerrilla group of parents started a group called Computing at School. They're passionate that the knowledge of computer science isn't just a nice to have, it's absolutely imperative.
There's a famous quote from Arthur C. Clarke that said, "Any sufficiently advanced technology is indistinguishable from magic." So the thing I'm trying to avoid is children coming to believe that their sleek phones are essentially magic devices. They're made by wizards in other countries, inaccessible to them. And if they utter the appropriate incantations, then they will do good things. But since they don't know how they work and they cannot modify them in any way, they're essentially sort of disempowered users rather than being actively engaged and empowered citizens of the world. I think that's really quite important.
In 2012, the then Education Secretary Michael Gove called for a revisit of the entire school curriculum, and with the backing of the prestigious Royal Society, Computing at School put forward their report called Shut Down or Restart, and a proposal for a new national curriculum.
They said, say what you like, but it's got to fit on 2 sides of A4 to cover 10 years of education from year 1 to year 12. This is age 6 through to 16. And so that forced us to focus on the essentials. And its aims say, in black and white, in the statutory curriculum for the land, every child should learn the fundamental principles of computer science from primary school onwards and should have repeated experience of writing computer programs to solve realistic problems. That's quite an amazingly direct statement. It's not just saying digital stuff is important. It's saying computer science is a foundational subject.
I guess the challenge of a new subject is that you need teachers to be able to teach it.
People were saying to us, well, it'll never happen. Since we don't have the teachers and they won't be able to teach it, you might as well not try. But actually, if you talk to the teachers, they say, we're teachers, we can learn. And they can. So I'm really pleased that the British government has in the end, in 2018, decided to spend some serious money on training for computing teachers. So the National Centre is an £80 million 4-year programme of continuous professional development for computing teachers. It's very organised, very curated, very high quality materials, trying to give teachers something solid and dependable to cling to as they make this transition.
The goal really is for computer science to be considered a foundational skill, similar to mathematics or natural sciences. In a way, we're almost talking about a kind of societal base level literacy of computing, of AI, of all technology, in a way that could serve us now and in the future.
Well, in England, there was a big hoo-ha about trying to make an algorithm to decide students' grades in an age of COVID in which they couldn't actually take exams. And there was a huge national fuss about this. They ended up withdrawing from that and saying, no, we'll just trust the teachers to make judgments. But there was a lot of rather negative talk, right? The algorithm, decides something bad. But I think the conversation was along the lines of, oh, an algorithm is something computerish that I don't really understand. And it spat out some answers I didn't like. Whereas a well-informed person would think, I know what an algorithm is. I have written lots of algorithms. I know that they can contain bugs or that they are heavily conditioned by what you try to do and what inputs you give and so forth. You just have a much better informed conversation about that kind of thing. And it matters. That particular conversation mattered at national level.
What would you like to see happen over the next 5 to 10 years to prepare the next generation of workers for the challenges that they may face?
Computing as a school subject is not established. It's like a seedling that has, got green shoots above the surface, but it does not have deep roots. So I want to see computing embedded in a way that no senior leadership team could possibly say, oh, maybe we just won't do any computing in year 8, which is the case in some schools, now. They'd never say that for science, right? They'd never say that for maths. I want it to be equally inconceivable to say that for computing. I'd love to see more involvement from employers and for IT professionals. There's this big pool of goodwill and expertise and probably money, actually, and I'd like to find ways of connecting that up to what's going on in schools in a sort of deeper, richer way than the occasional careers talk. So just to give an example, this week, some students at Dartford Grammar School have been doing a kind of extended project involving genetic algorithms. They did a kind of show and tell with a couple of my colleagues at Microsoft Research, and my 2 colleagues sat and listened to their project presentations and asked questions and made suggestions and offered pointers. And I think the feedback that I got, I wasn't there at the session, is that was quite powerfully motivating for those students.
Yeah, wow. I mean, I'm just thinking, if I was a computing student, 16, 17, whatever, and got to present something to Microsoft Research, that would feel like a very, very big deal.
And it's not just Microsoft Research. There are thousands of companies around this country that are well-known and not so well-known, and they're doing genuinely interesting and innovative things, and that can help sort of explode some of the myths about the, socially challenged male geeks that are the only ones that do computer science.
If that struck a chord with you, then please do check out the show notes where we've shared lots of links about computing at school and how individuals and organisations can get involved.
I think if everybody folds their hands and says, hooray, the cavalry has arrived, the National Centre for Computing Education is here, problem solved, we can go back to sleep, we will fail, right? Education is a big, complicated thing. It needs all of us. It needs teachers, it needs schools, it needs senior leaders at schools, it needs the professionals, and it needs employers, and we have to actually pull together. And I think if we do, in this kind of collegial way, we can really make a difference at national level, and actually then I think at international level. I'm really excited about that.
Thanks, Simon. The use of AI and technology in a wider sense in the world of work presents a number of complex problems. But the hope is that with the right education, the next generation of workers will be prepared for the jobs of the future. And at the very least, they'll have a broader view of what this tech can actually do.
I still encounter quite a lot of people who have a science fiction oriented view of artificial intelligence. It's mathematics. Machine learning is fundamentally based on probabilistic mathematics. Deep learning is an evolution of that, AI and ethics. It's a big field. There's been a significant amount of work at it. And thanks to organisations failing at AI in ethics and recognizing that they failed to meet the ethical needs of an AI. There has been lots of work by a significant number of organizations to tackle some of these ethical considerations of AI.
It's impossible to sever the human element from AI and automation in the workplace. Luckily, there are lots of research centres, such as the Institute for Ethical AI and Machine Learning, that offer frameworks for organisations to tackle these issues. In this episode, we've spoken about bias, transparency, and explainability. And the big takeaway is that AI is very much misunderstood. It's seen as this kind of black box, spitting out answers that we just can't comprehend.
It is true, AI is a black box. But there's a lot of work happening now to simplify how that black box operates and allow you to understand how complex deep learning algorithms are arriving at decisions. This is available today, so you can apply this explainability to the black box today. It's a field of engineering and mathematics that's exploding. So we are getting to the point now where we can open up these mythical black boxes and really understand how they're working and how they're arriving at decisions.
With COVID as an accelerator, the world of work is irreversibly changing at record speed. The exciting opportunities of AI to advance society are profound. And for all intents and purposes, it's going to make our working lives much easier.
So the volume of data that we have today, 90% of it has been generated in the past 2 years. So it does mean the job landscape will change. AI is creating industries, it's creating jobs. And what we do find is it will move people from the mundane into being much more fulfilling roles, much more things that are high value in terms of where they spend their time, effort, and energy.
To live during the rise of such a powerful tool with such wide-ranging effects might seem scary. But maybe it's the discriminatory spaces, menial jobs, and disruptive diseases that should be afraid. You've been listening to Technology Untangled. I'm Michael Bird. A huge thanks to Matt Armstrong-Barnes, Toju Duke, Simon-Peyton Jones, and Mary Towers. And you can find a load more information about some of the topics we covered in the show notes. This episode was written, produced, and edited by Isabel Pollard, with sound design and mixing by Alex Bennett, and production support from Harry Morton, Alex Podmore, and Tom Clark. Technology Untangled is a Lower Street production for Hewlett-Packard Enterprise. Thanks for listening, and we'll see you next time.